Okay, so let's look at robot number one, which is the relatively simple robot. This one is just going to follow the commands we put into our program, and specifically this one, this robot should make a square. It should drive straight ahead from right to left, make a left-hand turn, and then do a 360, and then the last two legs of the square, the robot's going to go backwards. I'm a little distorted here in my square, but I think you're going to get the idea here. So let's see what he does. He's going straight, should make a left, left. Now he should turn around and go in reverse, third, fourth. So that's the four sides of a very strange looking square. I just have to make adjustments to the program to fix those 90-degree angles. It's obvious that the lengths look fine, but the angles are definitely not at 90 degrees. So we got to take a look at that. And as I say, this one's relatively simple compared to the IR and the whisker robot that we're going to look at in a minute. Number two I call whiskers. And obviously he has a pair of whiskers, kind of paperclip looking objects. These guys here. I find this guy really interesting. You'll notice that right here, I hope you can see that, there are three vertical uprights. And when I depress the left whisker, it hits that post and it closes the switch, and the computer picks up that closed switch, a current runs through, and it picks up a different voltage, a different current in the left whisker as opposed to the right whisker. Obviously when they're both depressed, they both hit their vertical posts and a different signal is sent out. And if there's a right one, so let's see what kind of turns this guy makes when his whiskers hit the board. So it looks like he's dead on, so he's going to hit both at the same time. So he's turning to his right, he's turning to his left. Let's see what's happening. I don't want him to stay in that corner. I'm going to put this at a bit of an angle. So you see what happened? Now he's going to hit that whisker and he's turning that way. Now I'm going to push that whisker, he turns to his left, turns to his right. When both whiskers are done, he turns to his left. So he should be able to stay out of corners with this whisker system. It may take him a while to get out of the corner, but eventually, yeah, I think he's going to get out now. He's out of the corner. So the whiskers are a nice way to keep your robot moving. As I say, I find him most interesting. You see the two red lights on top of the board. And these are more important for the IR robot that we're going to look at in a minute. Here's an LED 1 and an LED 2. Okay, LED 1 and 2. When a whisker hits, one is supposed to light up. When the other whisker hits, the other one's supposed to light up. And that's important. These LEDs are good indicators that your computer's working correctly. A lot of times if he comes head on into a wall and both are depressed, you don't know if it's working at 100% or only one of them's working. But if the LEDs are flashing, both are flashing, you know that he's 100% efficient. If only one LED is flashing, then you know he's only 50% efficient. So these LEDs are good indicators whether the darn thing's at 100% or not. So, IR robot, and this is the most sophisticated we'll be working on this year. These black tubes here are IR infrared emitters, and these two posts here, I hope you can see that I'm looking backwards on the camera. These two plates here are our IR receivers. So a robot comes to a wall, he shoots out these IR photons, and IR is just a form of light. These IR photons hit the wall, bounce off the wall, come back, and come into the receiver. Right receiver, left receiver. If they both hit at the same time, similar to the whiskers, he'll make a turn. If it hits the right receiver, he'll make a different turn. If he hits the left receiver, he'll make a different turn. So again, he'll stay out of walls. He'll stay out of corners, and he should prevent himself from jamming up in a corner. So as I say, this is the most interesting one. I found the most interesting one. Get him working here. Okay, so he's looking for a wall. He sees the wall. See, he keeps now. See that this space, unfortunately, is not big enough. If I had a bigger space, we could see what's going on. All right, so let's do it this way. All right, he's coming forward. At that point, he sees that far wall. Okay, so now everywhere he turns, he sees a wall. Unfortunately, so you know the horizontal walls are much too close to get a good feel for what's happening. But this is probably the best way to explain this. He's moving forward at a distance of about 2 feet. He pops off that wall over there. Now he's in this corner here, and his IR is keeping him out of the corners by just making short distances back and forth. Model here, and we could put in commands. We could tell it to do a square at different lengths, at different angles. We could tell it to do a circle as well as we can. It'd take a little bit of calculus, but we could do a kind of a circular, a squared off circle, if you will. And we could have it do different distances, and it'll keep repeating those commands over and over and over. That's the easiest model. Not as sophisticated as the other two. This is whiskers, and he's using these whiskers. Hitting both gives it one command, hitting left gives it another different command, hitting right gives it a different command. So it should be able to stay out of corners. And this is the infrared. The same sort of logic, but instead of whiskers bending, we're looking at IR photons being shot against the wall, bounced back, received at the receiver, and the computer figuring out whether my left photons are coming back, my right photons are coming back, or they're both coming back at the same time. The LED lights up top are good indicators. It shows you whether your robot is working at 100% efficiency or not. Okay, I wanted to give you a closer look at the board of this computer. Looking at my earlier video, I didn't want to give the impression that there's 3 different models here. This is the BoeBot Robot, and it's a basic robot, and they can be changed into whiskers or IR or a simple motion robot. It's all the same robot. It's just a question of whether you're going to put whiskers on or whether you're going to put the IR emitters on, or whether you're just going to want it to do a specific motion. So it's all the same robot, and the students will have a chance. I anticipate that something like this at the high school level, that's going to take us 2 or 3 months to get everyone up to speed on that, because we got to go through the electronics of it, the basic programming of it. The building a robot, you know, we can knock off in a half hour, but it's just the attaching these resistors and jumper cables and LEDs and programming this stuff that's the more time consuming. Then this middle part of our club year, I picture putting together whiskers, and then towards the tail end, the IR robot. So I'm thinking maybe a third of the time initially on robot number 1, and then a little bit less time on either the other 2 robots. And that should take the full year. But let's look at this, this board here. This white part with the holes in it is called the breadboard. Up here we have the power. This black single row up here is the power, VD, VIN, and VSS. It's just like the positive and negative terminals of a D cell or a AA battery. These jumper cables just connect the power supply to the instrument. Here we have our piezo speaker that's given us our buzzer at the beginning and ending of each trip, of each program. These here are resistors. Spend a lot of time on resistors in physics. Resistors just increase or decrease the flow of current in a circuit. A high ohm resistor, like a 470 ohm resistor, will allow less current through than a 200 ohm resistor. So those resistors are important. And these are the LED lights, the jumper cables. This is the electronic part of the robotics effort. I personally see 3 different parts to the club. Part 1 would be building the robot, and as I say, 1 or 2 meetings, and we could bang that out. The second part, the first part is building the robot, which includes the electronics, putting these cords, resistors, and jumper cables in the right positions, and that might take 2 or 3 periods. Then the second part is the computer programming, and like me, I have very minimal exposure to computer programming. The most I've done has been this summer. So the students, it's a whole different language, but it's interesting stuff. I find it interesting, and once they get into it, I think they'll get hooked on it. But the computer programming is important. And then the third part is actually doing some functions, making this guy do a circle or do a square, keeping this guy out of corners, and the infrared, understanding that we're shooting photons of light, and also it's keeping it out of corner. And one thing I didn't mention about the IR model here, we point these IR emitters straight down, and what can they do for us as you're bringing it towards an edge? If we programmed it correctly, the IR emitters tells us when the table ends and causes it to turn around. So I can take out this flimsy wool structure and just allow the IR emitters to identify the edge and tell the computer to turn around. So that's a different set of programming other than the programming to keep us out of corners. Okay, that's pretty much it. Thank you.